everyone, my name is Olivia Clark, and today I'm going to be talking about the PISA 1 protein. Here's my 3D model shown right here. So the PISA 1 protein is located in the membrane part of the cell, which is the outer layer. And specifically, I'm going to be talking about the R2456H mutation, which is related to pulmonary hypertension. So that's basically affecting the red blood cells and blood pressure. So the PISA 1 protein is pretty complex, talking about its shape. It has almost like a fan-like shape. So this kind of allows for it to sense and respond to mechanical forces, so things like stretching or pressure. And it's often described as having like a domed shape almost, with large extracellular tubes, so like these shown here. So the PISA 1 is a large protein with multiple membrane spanning regions. So it kind of forms a channel through the cell membrane with parts that extend inside and out of the cell. So this protein includes helix bundles, so like alpha helixes in a structure, and these helixes help form the channel. PISA 1 is typically thought to function as a single polypeptide chain, but it has regions that interact within itself in a way, so it can be like a subunit interaction almost. So the different colors kind of represent the different subunits with the different functional parts. So like these are like the subunit like interactions shown in the different colors. So PISA 1 is mainly to have a linear structure, so the primary structure. So different, that's what you can kind of see here. And then the secondary structure kind of includes the alpha helixes and the beta sheets. So that's like the coiled-like structures. Tertiary is like kind of just the overall 3D structure of the protein. And then most of them don't have a quaternary structure. So now moving on to the mutation. This is my mutation model here, and the silver is kind of representing the mutation part. So this mutation changes the amino acid arginine to histidine at the position 2456. So the mutation has to do with the protein's folding and stability. So it's basically in areas where the amino acid interacts with other parts of the protein or the lipid membrane, which is like kind of shown in the middle with the silver here. So the mutation makes PISA 1 protein like less sensitive and less effective to responding to mechanical pressure. So this kind of affects the cell's ability to sense the stretch or pressure. So with diseases like pulmonary hypertension, this leads to problems with blood pressure or red blood cell function, as this mutation kind of alters the protein's normal activity. So moving on. The mutated amino acid is located in the transmembrane domain of PISA 1. So that's again shown here on the silver. So this is what helps this channel lets the ions through the cell membrane. So that's the different colors. So it's showing like the channel. And this model does have a few limitations. It doesn't quite show the accuracy of the folding. So it's not fully as complex or dynamic as what a real protein would show. PISA 1 is very large in size, so this model is not quite as large as the real one, and then it doesn't quite fully interact how it would interact with the lipid membrane, which is the key aspect of its function, as I talked about earlier.